All right, so I accidentally hit the stop sharing button on the last one, so we'll finish this one up. But this was break it up into two videos. That was 20 minutes anyway, so this equals 1.43. Get the two z-scores. The last one of 12 randomly selected customers. Now, this is a probability question. 12 randomly selected customers, what's the probability exactly for will request size medium? So we just found that the chance of medium is 19%. Okay, so this one, out of 12, what's the chance for request it? So this one is a binomial PDF. We have 12 customers, 19% chance of success, and exactly 4 request medium. So it's about 12%, 1195. This is the formula for the binomial that it is helpful if you know. Probability X is 4 equals 12, 4.19 to the 4 times 0.81 to the 8. And that equals 0.1195. But you have to recognize that's a binomial problem. Now, you can do the binom PDF and explain all those things as you're working that one, and that would also be acceptable. But that one shifted gears from normal curve. Number 3, trains carry bauxite ore from mines in Canada with aluminum processing in northern New York State in hopper cars. Just a second, I'm going to plug in my computer so I don't lose power. All right, so just want to make sure we don't have one more issue. I'll try not to hit the stop sharing button. Trains carry bauxite ore, New York State, in hopper cars. It has a mean of 70 tons. So here's our mean. Here's our standard deviation. Here's normal. As soon as you see those three things, you know you're dealing with a z-score question. So I don't have much room, so I'm going to do part A. We're going to do that down here. It says, what's the chance it will be 70.7 tons or more? Okay, so we're going that way. If we do the z-score, we get 70.7 minus 70 over 0.9. That's a 0.777 z-score. We'll grab our normal CDF. I'm going to use the z-score this time. Since I'm using the z-score, remember I leave these 0 and 1. If you want to use the other values, you should get approximately 22% the other way. And the one part about statistics, if you round a little bit, we're not like AP Calc. If you've taken AP Calc, we don't sit and worry about rounded to 3 decimals. We're not trying to build bridges. We're trying to estimate the chance something happens. So 22% chance it's over 70.7. Now, of course, you can use the normal CDF if you want, and you can put in the lower bound and upper bound and label all those things, and you'll get credit for the z-score. So you don't need that 0.777 z-score that way. B, suppose the weight of the ore is 70.7 tons. What would make you suspect it's overfilling the cars? Would that fact make you suspect it? And the answer to part B is really no. Okay, it's 22% chance. This is really a p-value question. That's greater than 5%. I'd fail to reject any null with that amount. 0.22 is bigger than 5%. So you can go on to explain that that's not a rare occurrence. if we got something like a 1% chance, something that would be less than a 5% typical alpha level, then we might reject the null and say, I think they are overfilling the cars. But this probably is just due to chance, natural variation, random natural sampling variation. So anytime you're asked, would you suspect something, think about that we're really dealing with an alpha level, and is something rare. If something's rare, yeah, that makes me suspicious. That's why we reject the null when things are lower than 5%, because we think it shouldn't have happened from natural sampling variation. All right. A professional sports team evaluates potential players for a certain position based on two main characteristics: speed and strength. Speed is measured in the time to run 40 yards. And from previous speed data for all players, the times to run the 40 yards have a mean of 4.6, standard deviation of 0.15. I guess I have them there too, with a minimum time of 4.4 shown in the table. Based on the relationship, is it reasonable to believe the distribution is approximately normal? Okay, so now this one doesn't say it's normal. So let's look at this and let's think about this. If this is 4.6, if we were to go and we add the standard deviation, 4.75, 4.45, 4.9, 4.3, 4.15, and 5.05. If our minimum happens to be 4.4, where is 4.4? Let's do a z-score. (4.4) is our x. Remember, it's xylophone minus mu over snake. So we got to subtract the mean, 4.6 over 0.15. Our very minimum value is only 1.33 standard deviations away. So our answer is, since the minimum is 1.33 below, that's the negative, it is likely skewed right. If something's normally distributed, I would expect my mean to be somewhere in the area of 3 standard deviations below. I mean, it could be 2.7, something like that. But why is my minimum only 1.33? That means and here's the reason, there's a lot more ways to be slower. Okay. So faster is harder. So it kind of peaks over here, and then a lot of people can be slower. Okay. I'm sure I could break the maximum record for speed on that. All right. And if you think about that, you'll understand what I said, that I'm not super fast anymore. All right. Strength is measured by the amount of weight lifted, with more weight indicating more desirable strength. From previous data, we have the mean and we have the standard deviation. Calculate and interpret a z-score for a player who can lift 370 pounds. Okay. Now it says nothing about normal. So in this question, no percentages should be given. It's just asking you to do a z-score. So the player can lift 370 pounds. We subtract 310. We divide by 25. So let's get that z-score in your calculator. I love the control divide feature on here. (370 minus 310 over 25). Throw a dot on. It's 2.4. Okay. This lifter lifted a weight 2.4 standard deviations above the mean. That's it. That's the interpretation. When they ask you to interpret something, don't make it hard. Usually, interpretations are easy. For instance, a residual, calculate a residual interpretation. You got a negative residual. Oh, the person did less than expected. You got a positive residual, thinking about the line with residuals. A positive residual, the person was higher than expected. Okay? Negative residual, they're lower. Positive, they're higher. That's positive residual. That's a negative residual. The line is the expectation, and the same thing's true. You always subtract the mean with residuals. E equals y minus y hat. The line is the mean, so you always subtract the y line. Okay, hopefully that jogged your memory on some things. I do want to touch one more thing. Remember percentiles, they're areas to the left. So if we said, hey, it's the 18th percentile, what's that z-score? Put in 18, and we get that z-score is negative 0.91. Remember, the middle z-score is 0. Here's negative 1. This z-score is a negative 0.915. It's not quite a standard deviation below the mean. When you start with an area, you use an inverse. When you're looking for an area, you use the normal CDF feature. Hopefully that's some stuff that you've remembered. That will be the end of video 2. Thanks for watching.